We are on the video now. So what I want to do now is, since I've shown you, given you the tools to be able to do molecular shapes, let's do that. We got 1 carbon and 4 hydrogens. Okay, the way I've taught you to do that is we're going to start with orbital notation. That's what we spent a lot of time in the last unit doing. In fact, we started off in the last unit with orbital notation. We're starting off with orbital notation again, using the same tool. So if you do the orbital notation correctly for carbon, you have 2 electrons in 1s, you have 2 electrons in 2s, and then you have 2 electrons in 2p. Right? And then we know we're going to have 4 hydrogens. And hydrogens have only 1 electron. Okay? I got 4 of them. And based on what you know so far, you would move those electrons or share those electrons with the empty orbitals that exist in carbon. Now, the way I'm going to show it to you right now is not really the way it works, but it helps you to figure out where we're going to go. Okay? Using what you would know so far, you take this electron and share it there, and this electron and share it there, and then you probably try to stick both hydrogens right there to get the a full valence level, right? And that would also give all the hydrogens a set of 4. Okay? But what really happens is something called hybridization. We will get to that tomorrow. And then we're going to need new balloons to do molecular shapes. So let's see, today is Thursday. Let's say by Monday you want to have a set of round and a set of long balloons. Okay, yeah.
Oh, so you need round balloons again?
Round and long, yes. Is that all you had to, okay, all right.
Yeah, I did.
So we're going to try to, remember in covalent bonding, it's more than just sharing electrons, you're sharing orbitals. So this orbital here joins up and becomes the same orbital as this one. Okay? And this one becomes the same as this one, and so forth. So, going straight to electron dot formulas then. Here's the electron dot formula for carbon, because there's 1, 2, 3, 4 electrons in the highest energy level, and each hydrogen just has 1 dot. And I have 4 hydrogens. Now I put the dots on 4 different sides for the hydrogens just because I know where we're going. Okay? You don't have to know where you're going. You can start with the dot over here and just reach around if you need to. Okay? It's perfectly okay, but just for right now, I'm trying to show how it all goes together. So these are the electron dot formulas for all the atoms we're working with here. And then we're going to get from that, we're going to go to the Lewis dot formula, but we got to go through the sharing arrangement to get there. So we're going to share these 2 electrons here, and share these 2 right here, and share these 2 right here, and share these 2 right here, and that gives every hydrogen the 2 electrons they want, and gives the carbon the remaining 1, 2, 3, 4 electrons it wants. Carbon then has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and has a full valence level. Hydrogen has 2 electrons and has a full outer energy level called the valence level. Okay? So that's our sharing arrangement. Okay? Then what we're going to do is we're going to squeeze the electrons in between the elements. I said to think about it like they're squishy rubber balls. And the more you squeeze them together, eventually they bump into each other and slide side to side. Okay? So that you end up with a shape like this. When I'm putting together an element left and right, the electron dots look like the wrong end of an over-under shotgun. Okay? And if I squeeze together electrons that are atoms that are above each other, then the electrons squeeze together in a way that it looks like you're looking at the wrong end of a double-barrel shotgun. Okay? Everybody got that? Anybody watching this video from somewhere else besides South Carolina might not understand why we're using the gun reference so much, but we're in South Carolina. Okay? So that's our Lewis dot formula. Okay? In case you don't know, we're a gun state, right? All right. Huh? What now? Really? Okay. Listen, I get emails through YouTube from people all over that watch these videos. Believe it or not.
Do you really?
Yeah.
Like, what do they type in?
Well, one guy said, this is confusing. Other people say, wow, I finally understood. Thank you. Stuff. It just goes around. It's a gamut.
Yeah, but what do they type in to find your videos?
Orbital notation, or
Why would you go to YouTube and type that?
because they're taking chemistry just like you and they're confused.
Why not go to, like, Khan Academy or something like that and type that in?
What the heck's that?
That's some Indian dude.
Yeah, but he's actually in the United States, but I've watched Khan Academy, and I really don't like the way they teach the theory. He really doesn't understand the theory. Okay, he does a good job of explaining how to get an answer, but he doesn't explain clearly and accurately the underlying theory. He's really good with the he started out with algebra. That's what it's. Huh? Right. He does a good job with algebra, okay? I just don't, if you want to just find out if your answer's right, that's fine. But if you want to understand so you can do better on the test after that, because you've got to understand the theory to get there, to build on it, I wouldn't rely entirely on Khan Academy, okay? I like it. Guys do a great job. Started out as one guy. I think he's got some other people working with him now. But in the chemistry theory, I wince sometimes when I watch some of those. So anyway, all right. So here's our electron, our Lewis dot formula. That's the name of it. You have to know that's what the name is. You have to know this is the sharing arrangement. You have to know we started out with the electron dot formulas. You have to know the names and be able to apply them. Now from here, we're going to try and arrange these 4 sets of electrons so that their sets are as far apart as they can be. Going back to this arrangement here, the reason we put electrons in these up arrows and down arrows is because we're showing opposite spins by doing that. And you can get 2 electrons in the same space within the same orbital because they have opposite spins, and it cancels the repulsion that you normally get with 2 particles of the same type charge. Okay? So even though we're not showing arrows here, you have to know that's what's going on. So we can get 2 electrons together in the same orbital. We can't put 4 electrons in the same orbital, or 3. Only 2, maximum of 2. So what we want to do is arrange them 3-dimensionally in space, so those 4 sets are as far apart as they can be. We've canceled all the electromagnetic repulsion we can. Now we want to kind of try to keep these 4 sets as far apart as we can get them and still have them sort of attached to the nucleus where the positive charge is. Okay? And for that, we're going to get that same starting shape that we got when I did water for you a while ago. Okay? So here's our central atom. I'm just going to put down a carbon symbol here. Okay? And we're going to have one set of electrons going basically straight up, one set of electrons going at slightly more than 90 degrees, but not quite 120. Okay? It's close to 110 actual degrees. And then we're going to have a set that's going to come out toward you, okay, swinging out away from the paper here. And that's how we draw it with that triangle. Anybody ever taken art and learn how to do perspective? Okay. Well, this is a way of kind of showing a super simplified perspective. Okay. And then the way we've always, when we've done drawings, you probably do this, for instance, elementary school. You put one thing behind another. The line you see, you put as a dotted line. What we're doing here is, this is actually behind the paper, so we're showing it with a dotted line. So this is going out behind the paper. Actually, I should make only 3 dots. I inadvertently made 4. So here's our other 2 sets of electrons then. Okay? And that shape, the geometry here is called a tetrahedral. The type of arrangement is called electron pair shape. Okay? So this is a tetrahedral electron pair shape. You can think of it like 2 names. You have a first name, you have a last name. The first name of this is tetrahedral. The last name is electron pair shape. Okay?
That's a name.
I'm just trying to help you remember it.
Picturing like naming a child.
Well, this is my child right here. This is my child. All right. So that's an electron pair shape, and it has its first name is called tetrahedral. Okay. Now, what we want to do at this point then is to replace any electrons that are shared up here with the atom symbol. Well, it turns out that all of these are shared, aren't they? This one's shared, this one's shared, that one's shared, that one's shared. There are no lone pairs like with water. They're all shared electrons. So all of these are going to be replaced. Does that make sense? So here's our carbon. I'm going to just take out this pair of electrons. Here's our hydrogen. This electron pair here is shared. I'm going to put a hydrogen there. This set of electrons is shared. I'm going to put a hydrogen on there. And this set of electrons back here is shared. So I'll put a hydrogen on there. Okay? Did we change the shape from here to here? No, the geometry is the same. So what are you going to name this? First name? Tetrahedral. Last name? Molecular shape. There you go. Yes?
Is there a reason why you only put 3 dashes instead of 4?
It's not all that special, but that's sort of like the convention for doing it. And it's just the way that everybody's always done it. Okay? I try to follow the convention so you see the example. If you gave me 5 dashes, I wouldn't count it wrong. Just the convention is 3.
Can I give you like 10?
Please don't push that. Come on. 2, maybe not. Yeah.
Can you skip the sharing arrangement? Can you skip any step?
At this point in time, I wouldn't.
Okay.
Okay. The reason I wouldn't skip any point into any step right now is because until you are so good at this, you can do it without thinking about it. You need to practice all the steps, because what it does is reinforce over and over again what it all means. Okay? I would not recommend you drop any step at this point in time. Now, we did this in the last unit, right? We drew orbital notation in the last unit over and over again. A lot of practice with that. You had to do it on your element cubes. So you've had a lot of practice with this. If you want to skip, if you can skip from this and go straight to the electron dot formulas, that's okay. But if you can't figure out correctly, and don't assume, I know what happens. The people that think they can do it and they're going to be good with it are the ones that are going to make mistakes. And the people that aren't sure, they're going to do this stuff, they're going to get it right every time. Okay? So I'm giving you all the tools to do it right. Okay? If you're not sure, don't skip this. Put it in there. Okay? That's how you make sure you get it right. Okay? We're building everything off of this anyway. All right? Got it? Questions? Okay? So you think you can do one for yourself now? Huh? Yeah? For homework, maybe? Hmm? What?
Don't we have a cube for homework?
Yeah, but this will. If you're sure about this, it shouldn't be too hard. You have another cube due tomorrow. That's the last one, right? This is number 4, correct?
Why did we do them all like within 2 weeks?
What do you mean? Why do we do them all in 2 weeks?
Like why did we do them all like together? Why didn't we space it out?
Because it's all part of Unit 2 material. I'm helping you to emphasize and re-emphasize, what the stuff on the periodic table is telling you. Okay? By doing this activity, you're reinforcing this is the atomic number. You're reinforcing this is the atomic mass. You're reinforcing the names and where they are on the periodic table. You're coming up with some interesting information, I hope, that's going to make other people go and look at the periodic table on the wall out there. And, people do. All right? You're reinforcing and practicing electron configurations and orbital notation and the charge numbers and where we get them from. Okay? Why we have them that way. Okay? So hopefully it's helping you to reinforce all the material you needed for, I know we just finished the test yesterday, but that was the idea. Yep.
Does anyone ever steal those?
Yep. Not very often, though.
Why would
No.
they want to steal those? I don't know, but I mean, I just don't want them to steal mine. It's a lot of work.
I agree. You still have the original, though, right, on your flash drive? Okay. I always recommend that everything you do in here, if it's electronic like that or digital, leave it on your flash drive. Yes.
Is it like a homework grade or?
It's a homework grade.
Okay.
Okay? All right. Now, back to homework. Assigned homework for today, in addition to the element cube that's due. Because by this time, y'all should be able to do element cubes in your sleep, right?
No.
Oh, man.
Not when you have 118 electrons.
You write them all out? I did.
Yes, hold on one second. I added that in there just for the people that were asking me the question about whether you need to show all this stuff or not.
Wait, what?
In other words, don't skip a step.
What was I going to?
Let's see, what would be a good simple molecule? What?
Helium.
Use quiet.
Oh, sorry. Helium's not even, doesn't even bond with anything. Did you say helium?
Yeah.
Exactly. Just for that, I'm going to give you a hard one.
No, let's do magnesium.
Oh, wait a minute, you can't use aluminum
When?
because it doesn't form, it's always a metal. Let me think about that a minute here. Oh, I know. Here we go. Okay, you got about 5 minutes remaining in class. That's not 5 minutes for you to sit and talk about other things and pack up and so forth. It's 5 minutes for you to get started on this, so if you run into a roadblock, you can ask me about it. Yes, sir.
When you say justify, you just mean show stuff, right?
If you're showing all your work, you're justifying your answer.